It is Miss Nelson here with day 7 of Unit 8. And our objective for today is how are relative humidity and dew point related? So we're going to get into what those terms mean, but to start, I want you to think about what is humidity and why does it seem like we only get humid weather in the summer? If you remember, from previous lessons, humidity is a measure of how much water vapor there is in the air. So if we have low humidity, there may only be one or a few water molecules in the air. But if high humidity, a larger percentage of the air is filled with water molecules. But why does it seem like we only get humid weather in the summer, if humidity is just a measure of how much water there is in the air? To answer that question, we have to remember how warm air acts and how cold air acts. So, first, we need to remember that warm air is going to expand and rise. So in this video, you can see this man is lighting a fire underneath a weather balloon. Do not try this at home or underneath a plastic bag. And he's waiting, and you can see that slowly, little by little, that plastic bag expands and expands out. And if we keep on watching the video a little bit longer, it's slowly still expanding as the air gets hotter inside. Soon, we will see that the plastic bag and this whole contraption will begin to lift up. So it's already starting to float a little bit. And now we can see it's lifting up and it rises. So this helps us remember that warm air expands out and will rise. Cold air, on the other hand, contracts and sinks. So if we remember back to when we put balloons in liquid nitrogen, which is extremely cold, about negative 300 degrees Fahrenheit, those balloons contract and they would sink down. Lastly, we can remember warmer air can evaporate or vaporize more water. So in the left, when it's 80 degrees Fahrenheit, you can see that the sun is vaporizing more water from the ocean than when it's only 40 degrees Fahrenheit. That puts more water into the air. But the key thing is that warmer air, because it expands, can hold more water vapor than cooler air. This is the reason why in the summer we experience more humidity. It's because the warmer air has the ability not only to evaporate more water or put more water into the air, but because warmer air expands, it can hold more of that moisture as well. Okay, but now we're going to try to answer our objective question, which talks about relative humidity and dew point. So first, relative humidity, which I'll sometimes shorten to RH, is how full the air is with water vapor, and we express this as a percentage. So if you can see below, we have three different air parcels. The first one is completely filled with water vapor, so it has 100% relative humidity. The second air parcel is 20 degrees Celsius. Remember that air has expanded because it's hotter. Is not filled as much with the water vapor. Only about half of it is filled with water. maybe a little more. So the relative humidity is 52%. And when it's even hotter and the air expands more, a smaller percentage of the air is filled with water, maybe about a third, or a little less than a third, in this case 28%. Since warm air expands, it has more space, and so if we keep the same amount of water vapor, that's going to lower the relative humidity. As we can see here, the temperature got higher and higher, so the air expanded bigger and bigger, but because the water vapor stayed the same, the relative humidity dropped. We're going to return back to a term that we've actually learned before, saturation. And saturation in the context of air is it occurs when the air contains the maximum amount of water vapor it can hold, or it's full of water. And this is going to occur at a specific temperature and pressure. So we've talked about this term saturation before. We've talked about a sponge being saturated or completely filled with water. And we've talked about ground or sediment being completely filled with water or saturated. But now we're going to talk about saturated air, or air that is completely filled with water. What's important for you to know is that when saturated, warm air can contain more water vapor than cold air. So if we have warm air and we completely filled it with water air molecules, and cold air and completely filled it with water vapor, the warm air, because it has expanded, can carry more. And again, this is why we feel that it's more humid usually in the summertime. When the relative humidity is 100%, the air is saturated. So if we go back to our example, when all of the air was filled with water vapor, we had 100% relative humidity. This air is saturated. It is completely filled with water vapor. And this is what saturated air might look like in real life. The other thing that occurs is condensation. If you remember from yesterday, condensation is when we take a gas and it forms and it turns into a liquid. It is that process. That is the reason why cold water bottles or cold glasses appear to sweat or have liquid on the outside. And it is also the process in the water cycle that creates clouds. It's when that water vapor in the air turns into liquid, we get clouds. There are a couple ways to change the relative humidity of a location. So, one way is we can put more water vapor into the air or take it away. So the first way is water vapor enters or leaves the air. The other way we can change relative humidity is by changing the temperature. So if we look at this diagram, process A over here is taking water from the ocean and putting it into the air. What's that process called? Evaporation. And evaporation puts water back into the atmosphere. How do we take water out of the atmosphere? Well, first we have to turn that gas into liquid water by condensation, but then it's going to rain out of the sky. What's that process called? Precipitation. So precipitation takes water out of the atmosphere and it'll put it back into a water body like the ocean or a lake. The other main vocabulary word for today is dew point. The dew point temperature is the temperature at which the air becomes saturated or filled with water vapor. The dew point temperature is when the relative humidity is 100%. So let me explain what I mean by looking at this diagram again. In the first diagram, we can see that the relative humidity is 100% because all of the air is filled with water vapor. So we can say that the dew point temperature is 10 degrees Celsius in that diagram. But the interesting thing is that the dew point temperature is 10 degrees Celsius for all of these diagrams. Because at 20 degrees Celsius, we would have to, in the other diagrams, we would have to lower the temperature to 10 degrees in order for all of the air to be filled with water vapor. So the dew point temperature is a way of measuring how much water vapor is in the air, and it tells us the temperature in which all of the air is filled with water vapor. All right, so what happens at these different, when the dew point, for example, is lower than the air temperature? So in the example that I've pointed out here, the air temperature is 30 degrees Celsius, the dew point is 10 degrees Celsius, so the dew point we can say is lower than the air temperature. When that occurs, condensation will not happen. Because not all of the air is filled with water vapor, the water vapor will stay in its gaseous form. It doesn't need to turn into liquid. But in this case, when the air temperature is the same as the dew point temperature, they're both 10 degrees Celsius, the air cannot contain all of the water vapor, so condensation will occur. Some of that water vapor will turn into a liquid. That's when we get clouds and when we get that water on the outside of water bottles or glasses. Regardless, dew point temperature is never going to be greater than the air temperature. If we look at our example, the dew point temperature was always 10 degrees Celsius. The air temperature was never below 10 degrees Celsius. Okay. The closer the air temperature is to the dew point temperature, the higher the relative humidity is going to be, and the greater the chance of precipitation. So I have a graph for you below that shows how the air temperature changed over time and how the dew point temperature changed over time. By looking at that graph, I want you to answer two questions. The first question is, what time of day is it most likely to rain? Or what time of day are we going to have the highest relative humidity? And what time of day is it going to be the most dry? Or what time of day are we going to have the lowest relative humidity? I'm going to put 1 minute on the clock. Take a look at your notes and the diagram and see if you can figure out and label on your diagram when it is most likely to rain or have the highest relative humidity. And label on your diagram when it is going to be the most dry or has the lowest relative humidity. I'll check back in with you at the end of the minute. All right. So the first question is, what time of day is it gonna be most likely to rain? We have to remember that the highest relative humidity is going to occur when the air temperature is closest to the dew point temperature. That occurs right here. So you can label on your diagram, circle that location, or highlight it, and write that that is where we're going to have the highest relative humidity and where it's most likely to rain. To answer what time of day that occurs, we have to read down to the graph, and we can find out that that will occur at 6 a.m. The time of day that's going to be the most dry or have the lowest relative humidity is when the air temperature is the farthest from the dew point. That's right here. So you can label on your diagram that this is where we're going to have the lowest relative humidity, and this is where it's going to be driest because the air temperature is separated from the dew point temperature by a lot. If we read down to find the time of day, we can see that that occurs at 4 p.m. So that is our lesson for today. I hope you learned about relative humidity and dew point. Tomorrow, we are going to learn about how we measure those things and calculate them using a reference table. But for today, your exit ticket is please send a picture of your notes and the answers to the exit ticket below on Remind to Miss LaPlaca. She's going to be the one that's going to be grading them and entering them into the gradebook. And please answer the questions below. So the first question is, which graph best shows the relationship between the probability of precipitation and the difference between air temperature and dew point? And the second is, you have to pick which statement best explains why an increase in the relative humidity of a parcel of air generally increases the chance of precipitation. As a reminder, if you need any help with them, Ms. LaPlaca or I will be happy to help you. And I hope you guys have a safe and happy day. All right, see you tomorrow. Bye.